Okay, practice problem number 4. Reflect triangle ABC across the two intersecting lines. Then describe the single transformation that occurred to map the triangles onto each other. Okay, so to start off, first we must reflect this triangle onto, since these two are the intersecting lines, we must first reflect it on this line. Once we reflect it on this line, we must reflect it onto this line. Okay, so first, you gotta plot out your points. Okay, now, since this is the y-axis, and we know what the formula is for that, it's the x becomes negative and the y stays the same. So for all these points, so for this one, 2 would become negative and 3 would stay the same. So let's just add a negative point here, and that would be negative 1, 2, 1, 2, 3. So that would be point A on the reflected triangle. And for B, you just add a negative here. It would be negative 1, 2, and 1 up. So B would be here. And C would just be negative 1, 2, 3, 4, 5, and up 1. So that would be C. Okay, so after we reflect it on one line, we have to reflect it on the other intersecting line. Now what we're doing is that we're reflecting it on the x-axis. And the formula for reflecting on the x-axis is x stays the same, but y turns negative. So for A, this time, negative 2 stays the same, but the y goes negative. So this time it'll be negative 3. For B, negative 2 stays the same, and this time 1 will be negative, so negative 1. And then for C, negative 5 will stay the same, and 1 will change to negative 1. Alright, so let's plot out these points. So A, 1, 2, negative 3. So that's where A is. B, negative 2, 1, 1, 2, negative 1. That's where B is. C is negative 5, 1, 2, 3, 4, 5, negative 1. And that's it. So, since theorem for two shapes reflecting across intersecting lines states that the angle between the two intersecting lines doubled equals the angle of the whole rotation. So from here, from this triangle to this one. So if it's supposed to be double the angle between the two intersecting lines, that would make this a 180-degree rotation. Okay. So let's see if that's true. we know that the equation for a 180 rotation is x and y. The ordered pair turns into negative x and negative y. So, if this is a 180 rotation, then point A, B, and C have to match this equation after the rotation. So, point C, B, and A have to both have a negative x and a negative y value for this to be true. So let's check and see. So A started off in 2, 3. A started off in 2, 3. And after the rotation, it's in negative 2, negative 3. So we know that's true. That proves that it was a 180 rotation. But let's just keep going to show you that it's true for all the points. B started off as 2, 1, and after the rotation, turned into negative 2, negative 1. And then C started as 5, 1 over here, and turned into negative 5, negative 1, as seen over here.